Our next problem appears to be a very small and simple problem, but involves a very important concept, which is the concept of Sandwich theorem. Now we are to find out the limit of bracketed x upon x as x tends to infinity. Now this question cannot be solved by the usual methods which we do. Instead, we have to use the approach of Sandwich theorem. This Sandwich theorem can be applied in all those cases in which we can write any of the function in some inequality form. Because in Sandwich theorem, we are given with a function f of x whose limit we need to find out in inequality form. We find out two functions such that one of the function is greater than that function and one of the function is lesser than this function, and then we check whether the limit at the desired point of the two functions which we found out are equal or not. If they are equal, let's say equal to L, then by Sandwich theorem we can very easily say that limit x tending to a, f of x will also be equal to L. So in all those functions which can be written in some inequality form or which can be expressed greater than a function and lesser than another function, in those questions we could try out Sandwich theorem approach. Here we know that the bracketed x function is always less than equal to x and greater than x minus 1. So a given function which is, let's say, h of x, it can be written as, on dividing both sides by all the sides by x, we get bracketed x upon x is less than equal to x and greater than x minus 1 upon x. So this is our h of x, which is less than equal to 1 and greater than 1 minus 1 upon x. Now we try to find out whether this function and this function are having the same limit or not at x tending to infinity. This is 1, which is a constant function, and x tending to infinity, this will be equal to 0. So this is also having the limit equal to 1. So we can very easily say by Sandwich theorem that limit x tending to infinity, h of x, which is our function bracketed x upon x, it will be having the limit equal to 1, which is our final answer.